Hello, Algebra 2 students. Mrs. Allison here, and today we are going to look at synthetic division, day 1. So first, before we actually look at synthetic division, let's talk about long division. So long division is something that you guys did back in elementary school where you divided numbers. We're now going to look at dividing polynomials. So notice here I want to take 2x cubed plus 5x squared minus x plus 7 and divide it by x minus 2. So if I want to do long division with that, I'm going to put the x minus 2 on the outside and the polynomial I want to divide into on the inside, just like that. So then what I'm going to do is I'm going to see what I have to multiply x by to get 2x cubed, which would be 2x squared. And I'm going to go ahead and multiply both the x and the minus 2 on the outside by 2x squared. That'll give me 2x cubed minus 4x squared. I then change my signs. So this is going to become minus, this will become plus, and I combine my like terms. When I do that, my 2x cubes cancel, and 5x squared plus 4x squared is 9x squared. I will then bring down the minus x and the plus 7. And I'll start the whole process all over again. I'll see what I have to multiply x by now to get 9x squared, which would be 9x. So I'm going to go ahead and multiply both terms by 9x on the outside. So I get 9x squared minus 18x. Change my signs. Add my like terms, giving me 17x. Bring down my plus 7. And then last thing, I will multiply, see what I have to multiply x by to get 17x here, which would be 17. Then I multiply both terms by 17, giving me 17x minus 34. Change my signs. And then I add my like terms, giving me 41. And 41 would represent my remainder. Okay, so I would write my answer as 2x squared plus 9x plus 17, and then plus my remainder. Now, you're probably feeling a little overwhelmed and thinking, wow, that was a lot of work for that simple answer. So we're going to show you a different method. And there's my answer using long division, with my remainder over what I divided by. Synthetic division is very similar, but it's a fake division. It kind of takes out the x's and makes the process a little quicker. So to do synthetic division, which is what we're going to choose to do in this course, is what we're going to look at is we're going to look at all the coefficients in front of my terms. So I have a 2, a 5, a -1, and a 7. And then I have to figure out the 0 I'm going to divide by. So I would take this as a factor, x minus 2 would be a factor, set that equal to 0, and I would get 2. So I'm going to divide out 2. Then from here, we're going to bring down this 2 here, and I'm going to multiply it anytime it's outside the box by the 2 on the outside. So 2 times 2 gives me 4. So that will go on the inside. Once it's on the inside, I will then add my terms together, and that gives me now 9. And then I start that process over again. 9 multiplied by the blue 2 on the outside gives me 18. I'll then add -1 plus 18 gives me 17. Then 17 times 2, remember the blue 2 on the outside, is 34. I then add 34 plus 7, and giving me then 41. And remember, 41 is our remainder. So normally I put a little dotted line there to remind myself there's my remainder. And because we had a cubed function originally, and I divided out an x of 2, I now have made it a quadratic. So I'd write 2x squared plus 9x plus 17 plus my remainder over what I divided by. Notice, either way, I still get the same answer. Okay, so we're going to stick with synthetic division for this course just because it's a little bit quicker than long division, a lot less steps to do. Now, why do we even use synthetic division? Well, we use synthetic division to allow us to find all of the zeros of a polynomial. Remember, we're finding where it crosses the x-axis as in the picture shown below, or to the right. So our goal is to find all of these zeros when something's not factorable or when we can't use quadratic formula on it. So let's take a look at another example of synthetic division. Okay, so here I have a quadratic. So once again, I'm going to figure out what my terms are. So this would be a 1, a 4, and a 3. And I'm going to stick those on the inside of my box. I then have to find the 0 I'm going to divide out. So I would set this equal to 0, because remember x plus 1 is a factor, and I would get -1. So I'm going to divide -1 out of my polynomial. So to do that, I'm going to bring down the 1. Once it's outside, I multiply by the number out on the outside. So 1 times -1 gives me -1. I then add, and that will give me 3. I then multiply again. 3 times -1 gives me -3. I then add, and my answer is 0. That is your remainder. Okay, this number, your last number, is always your remainder. So I'm left with, remember I started with an x squared, I divided out an x, so I'm left with the factor x plus 3 when I divided. Okay, now one thing I do want to point out is sometimes we'll get a remainder of 0 and sometimes we won't when we divide. So what does that mean? Well, if you get a remainder of 0, just like if you divide two numbers, that means that the polynomial or is a factor, or the number you're dividing out is a 0, root, solution, x-intercept, however term you want to use there. Okay, but that's letting you know that that number is a 0 of your polynomial. Just like if I took 25 and I divided by 5, I would get a remainder of 0, because 0 or 5 is a factor of 25. If I divided out 4 from 25, I would get a remainder not 0, because 4 is not a factor of 5. Or of 25. Okay, so if we go back to this example here, I can see that x plus 1 is a factor of that polynomial, or I could say -1 is a 0 of that polynomial. Okay, so just to emphasize again, the difference between factor versus 0, a factor would be x plus a number or x minus a number. Okay, so here in my example, x plus 1 is the factor. The 0 is what x equals. So x equals your number would be your 0. Okay, so let's take another example here. I want to know if x minus 1 is a factor of this polynomial. Now, one thing we haven't talked about yet that you'll notice here is that in this original polynomial, notice it's a cubic. So I start with a 3 as a cubic. I then have a -5 as an x squared, but I'm missing my x term. You have to have a term for every, you have to have a number for every term. So I'm going to put a 0 in as a placeholder for my x term, and then -2 for my last number. Okay, so I have 3 for the x cubed, -5 for the x squared, 0 for the x term, and -2 for my constant or the last number there. And then remember, I'm going to set this equal to 0. I'm going to set the factor equal to 0 so I can figure out what number I'm going to divide out. So I'm going to divide out a 1. So then I will bring down my 3, and once it's outside, I'll multiply. So 3 times 1 is 3. I will then add -5 plus 3 gives me -2. I will then multiply. -2 times 1 is -2. I'll then add 0 plus -2 gives me -2. And then I'll multiply. -2 times 1 is -2. Last thing is addition, which gives me then -2 plus -2 is -4. So is this a factor? Well, no, it is not a factor because I have a remainder that is not 0. Okay, so this would not be a factor. And that's because I have something other than 0 as my remainder. Now, the polynomial that I have left, just to explain, this would be 3x squared minus 2x minus 2 if it asked me for the remaining factor once I divided. Okay, but the important thing to remember here is that this is x minus 1 is not a factor because I have a remainder other than 0. Okay, so let's look at this example. Once again, I'm going to set x plus 2 equal to 0, and I'm going to divide out negative 2. So I'll use my coefficients here. I have a 1 for the x cubed, a negative 1 for the x squared, negative 10 for x, and negative 8. Okay, so then I will bring down the 1, multiply, that gives me negative 2. Negative 1 plus negative 2 gives me negative 3. Negative 3 times negative 2 is 6. Add, that gives me negative 4. Multiply, gives me 8. Add, and I get 0, which tells me then that this would be a factor because my remainder is 0. Okay, that would be a factor because my remainder is 0. Last example here, you should notice something slightly different about this example. Notice I don't give you the factor, instead I give you the 0. Okay, so we don't have to worry about setting it equal to 0 and finding the number. I'm given the number I want to divide out, so I want to divide out 1. That's my 0. Now, one thing remember here, I'm missing a term. I have a 3 for the x cubed. I don't have an x squared, so I'm going to put in a 0 for a placeholder for x squared. Negative 2 for x, and 5 in for my constant. So I'll bring down my 3, multiply by the number outside, so 3 times 1 is 3. I will then add, which gives me 3 there, and 3 then times 1 is 3. I'll then add, and negative 2 plus 3 is 1, and 1 times 1 is 1, and I will then add one more time to give me 6. So, is this a 0? Hopefully you said no, because the remainder is not 0. Okay, so no, that is not a 0, not a solution, not a root, because I got a remainder other than 0. Okay, so now you can complete the synthetic division day 1 practice. Have a great day and let your teachers know if you have any questions.